Today it's my pleasure to introduce Dr. Vipin Swarup, who comes to us from Mildhance, the MITRE Corporation. Dr. Swarup actually is returning close to his old haunts. He got his PhD at the University of Illinois, doing work in formal verification, type verification systems. More recently, well, since then he's worked in quite a few areas. He was a pioneer in mobile agent security and done a lot of work related to information assurance. So I'd like to welcome Dr. Swarup to the CERIAS Security Seminar.
Thank you. So in today's talk, I'm going to be giving a broad overview of research challenges in secure information sharing or assured information sharing. And this has been a grand challenge problem for several decades. What I'm going to do in the first half of this talk is give an overview of the current incarnation of this problem. Why is it of interest again today, and what are the new challenges that face us? And in the second half of the talk, I will actually go into 3 specific problem areas that we are interested in and working on. Now, sharing in a very general, high-level marketing kind of sense is that you do sharing because it brings data and people together to work a problem as a team. And I hope in the first half of the talk to do a lot better than this slide. But the problem space that we are in particular interested in the government is that you have a lot of federal agencies and other government agencies. Each of them have their own networks and their own set of data that they control. Now, clearly there's a need to share data across these organizations. So what they've done is they've set up a shared space in between, which allows these agencies to collaborate. And there's also pairwise sharing that happens among the organizations. Now, these agencies and organizations also need to interact with other state and local law enforcement. They need to interact with other foreign nations, other government agencies, international organizations, and so on. And the computing infrastructure is really quite complex. The solution so far really has been to build walls. We are on one side of the wall, and they are on the other side of the wall. And the walls are designed to protect us from the bad people. Now, this is great, and it's worked for quite a long time. There were 2 major challenges that came up when we built these walls. One is that we do want data to be able to cross these walls. In certain cases, we want good data to be able to cross. In other cases, we want to slow down the flow of bad data, of data that we really don't want to get across. And the second problem that we faced was that if you're on one side of the wall, you would like to have visibility on the other side. An analyst on a secret network would like to be able to browse the unclassified internet and find out what's out there. And the solutions that developed were largely along the lines of security guards that mediated flow of information across security levels. Now, this view has worked well for many decades. The problem is that the modern view is that it's not just pairwise interactions, it's a web of people, a web of resources, and the value that comes about from the internet really is in these unintended connections that happen between people, between resources, between organizations. And when we built these fine-grained walls, what we're really doing is we're cutting off the opportunity to have these unexpected interactions. Now, another challenge that really is highlighted by today's collaboration infrastructures is that I have a 5-year-old daughter, and if she has a secret and she wants to share it with her class, she doesn't stand up in front of the class and broadcast it to everyone. What she does is she goes to her best friends, pulls them aside, and whispers it in their ear, one by one by one. Now, that does several things. One is it makes her feel more important. It makes her friends feel more important that they're getting this secret information. It makes the information itself more valuable. It strengthens their relationships. And that's really the power of social networking. And I think we're seeing that on the internet in a lot of different environments, that social networks are critical to sharing. So whatever solutions we build have to be sensitive to this fact. The second complication that comes about is that we have data in all these different organizations, and they are situated in different security domains and at different classification levels, in different contexts. But what we want to do is we want to be able to fuse this and connect the dots, figure out what information can we glean by combining all this different information. And doing this when you don't have complete visibility into the entire data is quite difficult. The third issue that comes about is that so far we've been dealing with sharing on a very local scale, between two organizations, between a small group of people. It's like building a house. What we're now trying to do is do sharing across the global scale, on an internet scale. And the issue of scale really makes the solutions that would be appropriate quite different. Let me now go into a few scenarios that will help motivate some of the problems I bring about later in the talk. And the first scenario I'm going to describe is a first responder scenario. So let's say there's a fire that breaks out in a building, and the local firefighting department, they respond to the fire. Now, unknown to the firefighters, there's a warehouse next to this building, and the DHS and FBI, they have indications that there's a terrorist cell operating out of that warehouse, and there's some hazardous material, some biohazardous or chemical material. The fire now spreads into that warehouse, and the firefighters are about to enter it. Now, clearly the information about that terrorist cell and the hazardous material is relevant to that mission. It will help save people's lives, the firefighters' lives, the lives of other citizens around there. But these firefighters are usually the least trusted people. They're the frontline people, they're the least trusted in the organization. They are not given access to this information. And this is one of the central problems facing information sharing. How do you get sensitive information to frontline people who are usually not cleared for this information but have a burning mission-critical need for it? This is another version of that problem, and this is an instance where you have a police officer. He pulls over somebody in a car, takes pictures with a handheld PC, maybe scans a passport or driver's license or other piece of identification. This query goes to federated databases. The responses must be integrated, sanitized, and the response is sent back to this officer within a few minutes. He doesn't have much time. And this requires a lot of sensitive information to be processed, the results compiled, and then given back to the frontline officer. A third scenario, this is a battlefield mission scenario. So in this scenario, let's say you have two battalions. Battalion 1 urgently needs reinforcements. And the brigade commander wants to send the classified location of Battalion 1 to the commander of Battalion 2, except the communication channel has been compromised. The enemy has overrun the comm equipment and the security has been broken. So now the commander is faced with a dilemma. If he sends the information, the enemy is going to know it. If he doesn't send the information, Battalion 1 is in serious trouble. So on the battlefield, commanders must constantly make these kinds of risk-benefit decisions. In the commercial world, this happens as well, but in different contexts. A final scenario is a tax case agent scenario. So let's say you have an agent who's analyzing a virtual case file of a particular tax-paying entity. Now, this agent must deal with a lot of different entities. He must know information about tax shelters. He must have access to tax law expertise, revenue agents, a taxpayer, state and other international authorities. And all these agencies must share information to be able to figure out if there's some tax violation going on. Okay, so what I'm now going to do is moving into what exactly do I mean by information sharing. So I'm going to use a relatively informal definition of sharing, that sharing is the act of letting another party use data. Now, this has several implications. First, of course, is that there's a set of parties. There's some data, there's a set of objects that you want to share. There's a set of sharing participants, and these participants are going to play different roles. And finally, there's a set of different requirements. So you have participants who play roles of producers, consumers, facilitators. There's a set of different requirements that consumers need to be able to discover information, producers need to be able to discover consumers. They need to be able to access each other. Once the consumer gets the data, he needs to be able to understand it in order to use it. And finally, there's policy that cross-cuts all these three areas. And there are actions that are involved in each of these boxes. So producers must advertise the data, consumers must search them, facilitators broker. In access, you need to enable and obtain access and build the infrastructure so access happens. In understanding, data needs to be annotated, it needs to be translated and interpreted, and matching needs to happen. And finally, there's the policy side. Now, in this talk, I'm going to primarily focus on policy problems. But policy really undercuts each of the other three areas, and there are a lot of problems that I'm not going to be explicitly talking about, but that will come up if you actually look at each of those areas. Okay, so what inhibits sharing? Why doesn't sharing happen today? Well, first of all, consumers are unaware of data that they need. This is really a question of discovery and access, that people don't know each other's needs or what data is out there. There's a second problem, that is that consumers' information requests are ignored if they don't have the correct privileges. This is a policy problem, that providers today assess risks and need to know ahead of time, but they don't know what situations are going to develop. They don't know who's going to actually need the information. Individuals, on the other hand, they may have critical need for data, but they don't have the right privileges. And these situations, in all the scenarios I've described, these problems come up. And finally, there are other reasons of not being aware of context, of lacking sharing systems. And if you took a group of people and asked them, why doesn't sharing happen? Chances are every one of them will point to a different reason and claim that is the real reason sharing doesn't happen. And I think the real answer is that all of these are important. You need to address all of these for sharing to happen effectively. Again, in this talk, I'm going to focus primarily on policy. Let me first before getting into technical problems, let me first throw up a laundry list of problems that people face in the field of technologies that they need for sharing. So the first problem, of course, is protection for data at rest. Once you share data and it goes to the other person's system, it's at risk over there. It's susceptible to compromise and it needs to be protected. Data that is shared can itself have attack vectors in it, so you need to protect against data-driven attacks. There's a whole range of problems that come about over here, and I'm not actually going to walk through all of them. I'll just talk to a few of them. So the third one is to detect exfiltration or hidden data. Now, this hidden data can be deliberate in the form of steganography, can be malicious, or it can be accidental. And when you send a Microsoft Office document across the wire, chances are it contains objects that keep track of the entire history of edits you made to that document. Now, Microsoft has been working on tools to fix this, and the tools are available, but there are a lot of formats out there where you have a lot of legacy objects that are in the formats. The development teams today don't know what those formats are. So they just leave the objects in the representation. They don't want to delete them because that breaks certain applications. They're just left in there. And somebody who really understands those bits can actually extract what was there in the history of that document. And lots of sensitive data has been leaked in the past because of this. And it happens all the time. Companies send documents to other companies. It contains hidden documents, hidden data, and they get into problems. So we really need techniques to be able to detect this hidden data and to extract it and filter it out of these representations. Spillage, that's the last bullet over there. That one of the main things is that when data does get spilled, it compromises systems, and we need to be able to detect that and clean up after spills. Okay, let me actually move into the three areas of interest to us at present. And before I actually go into these, let me give an overview of the motivation of our approach. So when I began the talk, I motivated the problem as saying that what we're really talking about is a world where we have a social network, and we want to allow people who don't know each other to actually share data and communicate and collaborate. Now, the entire history of access control that we've been progressing along has been based on building finer and finer-grained access control mechanisms. And what these are designed to do actually is to block those unintended connections. So the perspective of this project, which we've taken, is really to take the counter approach and say, let's say we have coarse-grained access controls. We have communities, and we have a coarse-grained access control policy through which we admit participants into this community. And the community has a set of shared data within it. how do we now manage policy within this community? So every member of this community is allowed in principle to access all the documents within it, but we still want to have policies that constrain their behavior, and we still want to manage what sharing transactions happen. So there are three problems that come about, and three observations I can make. The first is that what we would like to do is to be able to make trade-offs between risks and benefits of sharing. So if a particular participant in this community tries to access a document, what we would like to do is understand why is he accessing it, what are the risks, what are the benefits, and make access control decisions based on that. The second problem is that all the technologies that we have today, security guards, firewalls, access control policies, they are fundamentally designed to block risky transactions. And what we really need if we're talking of sharing is we need a set of mechanisms that enable sharing. And the third problem is that the data that we're talking about really often doesn't have a single owner. Current mechanisms tend to take the approach that data is owned by the producers, and the policies are designed to protect the rights of those producers. And what we need are techniques that really have a symmetry. They protect both the rights of the producers and the consumers and other parties who are involved. So I'm going to talk about all three of these in the remaining slides. The first problem, of course, is this notion of risk-adaptive security. Now, the government has proposed this notion of RADAC, which is risk-adaptive access control, where the idea is that you vary access that's granted based on the changing threat level, the changing situation, the authentication strength, and so on. And similarly, people have proposed having dynamically tunable auditing, where if you have weaker authentication, you get stronger auditing. If you have fewer privileges, then you get stronger auditing, and so on. And the question, of course, is this too complex? Can we really build such a system and have meaningful properties that we can say about it? So what we really need to do is to understand what are mission risks and what are the benefits. So we want to have mission risks include things like, is there too much sharing or too little sharing? Because too little sharing can be just as bad as too much sharing. They're typically blunders that lead to spills. People have unapproved workarounds where they deliberately try and get information shared in violation of the rules because it's blocking their capabilities. Certain capabilities may be insecure, or they may not be perfectly secure. And what we need to do is understand how do all these things interact and how do we actually make these risk-benefit decisions. Now, there have been lots of approaches that people have proposed to do this. The first one is the simplest approach, but this is the one that's gaining traction in the government today, and that is to really use attribute-based access control. So the idea is you have attributes that represent both the risks and situational benefits of data. So these attributes have information about the environment, like the threat, about the current mission, about the sharing participants. And then you have a set of policy rules which are conditional, and you have decentralized administration with delegation. And a lot of the work that, for instance, Professor Lee's done provides the foundations for dealing with this kind of framework. Now, there are some additional elements when one wants to move this into a web-based framework, is that these need to be combined with cryptographic protocols. They need to be made web services aware. And there's some research going on at MITRE, for instance, on combining these three aspects of the problem, on taking trust management work and cryptographic protocol work and web services work and combining them into a single framework. Now, a lot of the work on risk-based access control was spawned by a report by the JSON group, and this has actually been written up as a MITRE technical report, where the idea is that let's say you have a system where you have tokens, and tokens represent the risk of a sharing transaction. Now, these tokens would be distributed by some central authority via some distribution channels, and every sharing transaction incurs a purchase price. So when you want to access a document, you have to pay a certain amount of risk tokens. And the purchase price is based on how risky is it for the sharing transaction to happen. The total number of tokens in the system is based on a total cap on the amount of risk that's allowed in the system divided by a risk per transaction. And the initial assumption is that every transaction has a fixed risk. Now, you can have different token currencies where each currency represents a different risk category. Documents can be fungible within a currency. That means that consumers have a choice, that given a specific token, they can decide which document to use to purchase with this token. And this permits consumers to actually optimize their use of their risk budget. They decide which documents are most valuable to them, and they go off and access it. Now, this has a lot of potential benefits. It incentivizes sharing. It maximizes the utility since consumers are managing the token use. It bounds total system risk. And this report is actually a very worthwhile read. If this problem is of interest to you, I would strongly recommend reading that report. It's food for thought. Now, another approach that's been proposed is extending label-based policies to deal with risks and benefits. So in the current MLS framework, what you have is you have security levels that represent essentially risk levels. The classification levels of documents represent how risky is it if this document, or what would be the impact if this document got into the wrong hands. The clearance levels of people represent their trust level. How risky is it to give this document to this person? In other words, how likely is it that this document would give this person would give the document to a bad person? Now, in this system, what you have is you have labels that represent both risk levels, which are the columns, and the benefit levels, which are the rows. The organization owning the asset determines the risk level. How risky is it if this document got into bad hands? The consumer actually determines the benefits to them, and the policymaker determines which one of the squares is permissible. Now, at every security level of a person, you would have a different set of diagrams, and the policymaker, by coloring in the right squares, would change the policy. And what this permits you to do is to align release decisions with mission needs. But there is, of course, the question of how do you convert this into a set of release guidelines, a set of rules that people can use to actually manage this. Another proposal that's been published is an access control model that balances risks and benefits of transactions. And the basic distinction between this work and the JSON work is that in the JSON work, they capped the total risk and they tried to maximize sharing up to that cap. In this work, what's done is the argument is that as long as a transaction gives you more benefits than risks, as long as it increases your total system benefit, you should allow it. And there is no cap on the total risk. Now, so far I've been talking about managing risks and benefits between two participants and looking at individual sharing transactions and deciding whether or not to allow it. Within this community view, the second approach that we are taking is to say that when you want to share information, you're not sharing it because the particular recipient needs it. You're sharing it because what they're trying to accomplish is important. And so even though a particular sharing transaction is disallowed, there may be other sharing transactions that can accomplish the same benefit that are allowed. So that was the basis behind this approach, that if CDC is trying to decide, should they share the sensitive information with firefighter Bob, they may feel that firefighter Bob is not trusted for this information. But rather than just saying no, they can do other things. They can, for instance, push the data to somebody else. They can push it to the fire chief. Let the fire chief take the appropriate action to save lives. They can redirect this access request to some override authority who temporarily gives Bob the authority to read this information. Or they can send both the data and the request to somebody on the field, maybe a police officer or some other trusted entity who's on the field, who can make the on-the-spot decision, should they give it to Bob or not. So the point over here is that the access control policy no longer is trying to decide should a particular sharing transaction be allowed. They're asking which of a set of sharing transactions should be allowed. Now, the third part of this picture is the notion of sharing obligations, that when you share data, it typically comes with a set of obligations. And these obligations essentially manage the risks and benefits of sharing. So the point is that when you share information, the risks and benefits are not incurred at that point. They happen after the fact, when the person uses the data, when they disclose it to the enemy, and obligations are essentially constraints on future behavior of participants. So for instance, if CDC sends the sensitive information to Alice, who happens to be the fire chief in this case, there could be a set of obligations that get generated, that Alice should be obligated to use the data. She shouldn't just toss it in the bin. Alice and Bob are obligated to protect the data. CDC is obligated to share regular updates with Bob, because it's important that Bob knows the current situation. Bob is obligated to notify CDC each time he shares it with somebody else, like let's say a police officer, and so on. That there are all these obligations that get created, and we need ways of managing these obligations. So what we've done is we've actually been working on building obligation models. So the basic model is very simple. You have a set of nodes that represent data stores, the principals and local data stores with typed values. The data flows are the edges, which represent data streams between principals. And obligations then represent temporal constraints on events over these data stores and data flows. Now, an important part of obligations is the notion of a penalty, because an obligation may not necessarily be enforceable. And what we want to do is that if an obligation is ever violated, we want to be able to impose penalties on the person violating the obligation. Now, at an abstract level, what one can do is express the kinds of obligations I spoke about in a language, for instance, in a variant of linear temporal logic. So the basic idea is that data store and stream events are expressed as predicates. Obligations are temporal constraints over these events. And the language essentially has a set of actions which give you a set of expressions which give you the source and destination of a sharing channel. And get lock gives you back the value stored in a particular location. There are a set of predicates, which are really the events we are interested in, which are send and receive of messages, and updating the location in a particular store, updating the value in a particular store location. And finally, there are a set of predicates, which are basically extensions of linear temporal logic, which allow us to express properties. So if I was to look at the examples I specified earlier and elaborate on them, the first example is responsive forwarding, that B will send C on a channel every object it receives from A within 24 hours of receiving it. And that predicate over there would allow you to express that. So what it's really saying is that if you receive O on channel C1, then you will send O on channel C2 in the next 24 hours. A non-disclosure agreement takes the form that if B receives an object O from A on channel C1, then B will not send O to any other principal for a year. Usage notification. This was the example I mentioned earlier, that if B gets an object, then for the next 365 days, if B sends it to somebody else, then B will notify A. Recurrence. A will send B the latest update to object O every 24 hours. Privacy. A must delete all personal information about B within 1 year of A storing it. Now, these obligations at the organizational level essentially get expressed in the form of sharing agreements. And the basic idea is that if you have organizations that depend on each other's information, and one organization changes its data representation or its semantics, that breaks software systems. And so what organizations typically do is they construct sharing agreements that encode these obligations, and they then manage these obligations. And so an important part of sharing that's done in the real world is actually to build mechanisms to manage these data sharing agreements. Now, what are the challenges that remain in this problem? The first problem, of course, is that today obligations are specified in English in the real world. They're Word documents. And we really don't have any effective language in which to express them. So semantically, we have deontic logics that we can use to express obligations at a very abstract philosophical level. We have linear temporal logic. That's the example I gave you, but it's way too powerful. It's more powerful than what we really need. And we have operational representations of obligations, which are really pairs of actions and time intervals. And none of these is really satisfactory. The action time interval doesn't allow us to express a lot of the examples I mentioned earlier. LTL is too powerful to express them. So what we really need is a representation that's somewhere in between these two. Analysis. Given an obligation we would like to be able to answer, is an obligation satisfiable? Does one obligation imply another? If I am obligated for one thing, is it okay for me to assume another obligation? Or is it redundant? Are there conflicts between obligations? If I am trying to share data with somebody, I require certain obligations to be satisfied. They have some notion of obligations. Can we find a match? Enforcing of obligations is probably, in fact, probably the hardest problem. That what we need is techniques that would allow us to manage obligations, keep track of them, represent them, allow us to know exactly what our obligations are. And then we need techniques to audit and monitor for compliance of these obligations. Now, this is actually a very hard problem because when you give data, the data is on the other person's computer, and yet you want to know that certain policies are being satisfied on them. This is a classic challenge that DRM faces, except over here we're talking about a different class of problems, or of policies. And if somebody does violate the obligations, we need to have penalties, notifications, exceptions, a lot of mechanisms to deal with those eventualities. There are a lot of extensions that are still needed in terms of existing frameworks. The first is that obligations occur in the context of certain organizations and tasks, and we need ways of representing them. And the second is that when data is derived, how do we figure out what are the obligations over derived data? And finally, there's administration. That how do we really organize obligations? How do we manage them? We know how to manage privileges. We have role-based access control to do that. How do we manage obligations? We know how to do negotiation. We have trust negotiation to do that with privileges. How do we do negotiation with obligations? There are a lot of open problems in this area. And in summary, what I'd like to effectively say is that the problem of dealing with policies in this new world of the internet requires a new set of mechanisms. We need to be able to express data channels between principals. That's fairly simple. We need to be able to manage risk-benefit trade-offs in the context of specific missions. So for instance, we want to share a patient's medical record with a nurse only if she is treating the patient. We would like to have the ability to specify alternate actions when a particular sharing action is going to be rejected. So if Bob requests an object and is denied, then we would like to be able to send the object to somebody else. And obligations. We would like to have the ability to satisfy constraints that parties are obligated to satisfy in the future. So for instance, if Alice receives an object from CDC, she must notify CDC if someone else gets the object. Now, I've given some indications of some approaches to these problems. If you have further questions, I'd be happy to discuss any of these approaches in more detail, or we can discuss this afterwards. So I'm going to end here and actually take questions if there are any questions.
Well, on your, I guess, slide 35, and the challenges. Yes. The linear temporal logic. Can you elaborate on that, please?
Okay, sure. So linear temporal logic is really allows you to express constraints on sequences of actions. So the idea over here is that if you have a sequence of actions, which are, let's say, sequences of message sends, receives, store updates, and the predicates that you have are actually up here. So oh, this doesn't work. Okay. A question of really parsing or specifying. It's a question of being able to analyze obligation specifications. That LTL certainly lets us express everything we would like to express, but we could probably do with a lot less and be able to have much more, be able to, so for instance, some of the properties I would like to be able to answer are, is an obligation satisfiable? Does an obligation subsume another? Now, these kinds of things you can do with LTL if you use model checkers, but in practice, we really shouldn't be using model checkers for access control. That if you had a simpler language and you were trying to, so the question is, why do we need to do this at runtime? And that really comes to the third problem. Let's say you have a pub sub environment, and the publisher posts some data with a particular obligation, and the consumer wants to subscribe to this data. That really requires you to match up these obligations, and that in turn requires the first two problems to be solved at runtime. So my point really is that what we need is a simpler version of LTL that's more efficient and that lets us answer these kinds of questions.
But how do we assume that the whole thing is linear anyway? How do we know that?
We don't necessarily accept that all of the examples that we've looked at we can express using LTL. And we've actually taken a large number of sharing agreements that were expressed in English in the real world among organizations, and we've been able to express every one of those policies that involve obligations using this language. And there's been some related work out of Stanford where they looked at privacy legislation, and privacy is very related to obligations, and they found that they could express every one of those policies using LTL.
You're referring to Michel's group?
That's right, Michel's work. So the language appears powerful enough to express most real-world policies that people express.
Yeah,
Yeah.
I mean, one of the things, and one of the arguments I think for your simplicity, it's not just real time, but it's also, I mean, this Bob agrees to obligations B, can we find a match? Well, in a lot of situations, Bob probably won't know what obligations they're willing to agree to until they see them. to be able to adjust these terms in, kind of what do you need to do to achieve these obligations given your environment? To what extent is that? I mean, is this? Have you looked at that very much in terms of given a set of obligations that that you are you able to look at a particular user's environment sometimes and filter that down and say, okay, these are the relevant portions? Is there any sort of simplification that can go on when you take a look at the greater environment?
I think that that's an open problem right now, and there are two aspects of that. So one is, depending on what level you express your obligations, it needs to get mapped down to system level events which you will actually be able to monitor or enforce those obligations. And in some sense, it depends on, do you express it down at the action time interval level, or do you express it at LTI? You need to map it down. The second problem then is, how do you actually enforce these obligations? And that really requires a whole trusted computing kind of infrastructure where you build up trust in your platform so you know that these things are being monitored and enforced on remote machines.
I guess what I'm thinking, for example, if I'm running on a high machine,
Yeah.
and a lot of the obligations deal with disclosure, conditions of disclosure to uncleared individuals, well, those are irrelevant to me. I'm in a high environment. It's not a factor. So, and that would seem a way you could simplify some of these. I don't know.
Yeah, that's a good point. Yeah. So the obligations would need to be simplified relative to the mission context.
Yeah.
Yeah.
Other questions? Thoughts? No, thanks, speaker. Yes, I'm receiving my emails, and I'm down to I'm still dealing at this point with things that are
I thought I was watching this thing and it went down to 0. So I was supposed to be watching that?
No, I think this is fine. I think probably went down to 0 at 5:10. Maybe.
Yeah.
Maybe so that is the 40 minutes for talk.